Those notes, so we didn't get quite done with the notes, nor did I give the entire assignment because we were not able to do all the notes. But let me, did we get to this one? I forget. No? But we were good with this one? We did this one? We did that one, but we didn't do this one. Okay. So let's remember a few things. Let's go back to this one just so we can talk through it. So we're talking about the first couple of perfect squares. Perfect squares go on forever, so it's not anything big. So remember, and just kind of review on what we did yesterday. If I'm multiplying things together, I can multiply outside to outside. So the 3 and the 2 give me 6, and then under the square root sign, I can multiply the 2 and the 12 together to get 24. And I know I did this one yesterday. I'm just trying to get us warmed up on that. So if you look at that. Then we say, okay, we can break down 24. And yes, 1 times 24 is great. Yes, you know that. And some of you might be, oh, well, 2 and 12 work. And 3 and 8 also work. And 4 and 6 work. And the reason I'm going to choose 4 and 6 is because 4 is the largest perfect square that is one of the factors of this number. Does that make sense how I stated that? And I know I did this one yesterday, so we have to recognize that we have this. Everyone agree that 4 times 6 is indeed 24? And then I can break this down, and I have the square root of 4 times the square root of 6. So the square root of 4 we know to be what? 2. Okay? So this, we know that will break down to 2. So let me bring this up top here. So then we get 6 times 2, because that 2 was square root of 4. The radical's gone now. And then I get square root 6 again. Now I have something else outside to multiply. So I can go 6 times 2 and get to 12. So my answer becomes 12 square root 6. And again, yesterday we talked about, exact answers are, they will follow you through math, but exact answers are used in a lot of places. Okay, and we talked about if we were to, and when we go to Mars, we want exact answers. Now, some people are like, oh, no, they have a landing area of like 16 square miles. And you're like, yeah, 16 square miles on a dot 280 million miles away. I don't know about you, but 16 square miles, 280 million miles away is not that big. And they're moving, spinning. Yeah, they're moving, they're spinning, we're moving. I mean, there's a lot of stuff that takes place, and we aren't at the point where we can just fire up the engines and drive wherever. As far as spacecraft go, we don't have that technology at this point. Will we one day? Oh, I don't know. I'd like to imagine we would. I have a great imagination. I love thinking about outer space and what it would be cool if we could have a Millennium Falcon. I mean, come on, that would be awesome. Outrunning the bad guys. That'd be cool. All right, so now let's look at this one. We're going to walk through it the same way. So let's think about this. What was my first step on the last slide? I multiplied the outside together. So I have -3, and I have 4 I'm going to multiply together to get me -12. And of course, I'm writing every step down. And some of you are like, I can see a step or two ahead. Good. But I'm going to write all the steps down just so we make sure we're with each other. And then, what's my next part? Yeah.
So the answer you would get is the answer that's in the perfect squares?
Well, it's all together.
Yeah.
So they hold on to each other. Okay, so then we multiply inside. And if I multiply 12 and 3 together, I get square root 36. Now, our perfect squares, we have 4, 9, 16, 25, 36, 49, 64, 81, etc. Okay, so those are perfect squares, and I don't have it listed on this board. So are any of those a perfect square that matches under the radical or any combination? Okay, now some people might say, oh yeah, 4 and 9 work, right? But others, you're going, what, you crazy? Right here, we got perfect square right there. And that's perfect square right there. So if I take the square root of a perfect square, what do I get? 6. So I get -12 as part of the problem times, there's no longer going to be a square root sign. I'm going to just get a 6. Okay, now I'm going to multiply negative 12 and 6 together, and that's going to give me, I believe, negative 72 if I do my math in my head right. And that's my answer. Where did the radical go? Well, we took the square root. It's gone. Okay? Make sense? Again, this is yesterday's notes, so we will do a little bit more. Okay. Have you all seen the Pythagorean theorem at least once? It should have been introduced to you probably between 4th, 5th, or 6th grade, depending upon the school you were at. Okay? If you haven't seen it, don't worry, I'm going to show you. But the Pythagorean theorem deals with the summation of the square of the sides summed together will equal the hypotenuse, which is the longest side of the right triangle, squared. Okay? And so they label the sides A and B and C, where A and B happen to be called the legs. In between A and B, we actually have a 90-degree angle. Pythagorean theorem works only when it's equal like that. You'll learn in geometry when you can use the Pythagorean theorem in other circumstances, but right now we have that. And what this means, what the Pythagorean theorem means, is I have A squared. What is a square? As far as just basic thought. No, go even more basic. It's a shape. Right? You learned what a square was, maybe kindergarten, I don't know. And you're like, it's got 4 equal sides. Good. Okay? So a square, if I talk about saying, hey, A squared, you're talking about really the shape of a square. And a square has 4 equal sides. The diagonals are equal to each other. All 4 of the angles inside of a square are all 90 degrees. They all sum up to 360 degrees. There's a couple other rules that go with it. But what it means when you're dealing with a square is this. I'm going to, let's see, let me erase this. And I'm going to see if I can do this. I don't know if I can or can't. Oh, dude. Okay. Let's move you. Can we move? Yeah, baby. Okay, let's move this. I'm going to move this over here. Okay? All right. So let's talk about what the Pythagorean theorem is. We called this side A. I'm going to make this to be a square that is an A by A by A by A squared. Make sense? If I found the area of that square, I would go side times side. So A times A. So what is A times A? A squared. Right? And if I were to then call this side B, and I were to make a square down here, and again, these, turn the page. So let's just pretend I'm really good at drawing. And I make this a B by B by B square. Still with me? And I'm talking that basic. So don't be like, man, he's overthinking. No, think about back when you start talking about what a square is. How do I find the area of this square that's B by B by B? It's B times B, which is B squared. And then I need to come up a smidge. And let's talk about this. This is side C. And so let's make this angle. Let's pretend this is actually a square. Let's pretend I'm really good at drawing. But this is a C by C by C squared. And if I were to find the area of this red square, it's C times C, which is C squared. So what the Pythagorean theorem basically means is this square, the area of this square, added to the area of this square is equal to the area of this big red square. That's what the Pythagorean theorem talks about. Okay, that's it. That's what the whole fundamental theorem of the Pythagorean theorem is. It's talking about something as a square, something as simple as a square that we learned so long ago. Okay? So that's what the Pythagorean theorem deals with. So it says, hey, if I take this and I add it to this, it's equal to this. The areas. That's what it is. Okay? Now, we're not going to have some other theorem that we're all of a sudden going to start using rectangles and triangles and you know, hey, we must make circles off each side. No. This is just going the fundamental basic. A triangle is the most basic closed-sided figure. It's 3 sides. That's the least amount of sides that you can have for a closed figure. So let's talk about how the Pythagorean theorem would work. Okay? So looking up here, I will enlarge mine a little bit. Let's see if that'll work. There we go. Okay. So I have A as a side, so that's unknown. I have 8 as a side. Okay, we know how long that side is. And I have 10 as a side. Now, just by looking at that picture, what would you assume would be our C value, which is our biggest value? 10. Everyone feel comfortable with that? So this is going to be my largest value. And again, I'm going very basic on it, but I want you to realize where this is coming from. That's the largest. So Pythagorean theorem says that if I were to take A squared, which, remember, that's square, plus B squared, B in this case is going to be 8, okay, is equal to 10 squared. So think about this. I have this square, and this square, and this square. If I add this square and this square together, I get that square. Okay? So A squared is just A squared, plus 8 squared is what? 64. And 10 squared is what? 100. And we learned like a long time ago in math that if we want to start solving for a variable, well, okay, we'll subtract 64 from both sides, see what happens here. Those cancel. So I get A squared is equal to 36. Okay? So if I want to get this 36 if I want to get A by itself, I want to take the square root of both sides. Because the square root of A squared is just A. And the square root of 36 is what? 6. So this side here is a size of 6. Do we feel comfortable with that? Okay, so the big key is, this is our, we don't have a test today. So that part right there, this is the newest part of math, okay? That's the newest part that we're looking at. Basically, realizing if I have A squared and I want to undo A squared, I take the square root of it. Okay, and there's other properties that are going to come along, but that's just our fundamental basic right now. Okay, so let's do this one. I'll make this a little larger so I can see it. All right, so looking up here, what is our largest side? Is it a number or is it a letter? It's a letter. Everyone feel comfortable with that? Okay, my A side, we could say call it 2, and my B side, I could call it 6, or I could flip-flop them. It's still going to be the same. But if I had 2 squared plus 6 squared, that's equal to 6 squared. So the area of this square and the area of this square is equal to the area of this square is what's going on. So that's going to be 4 plus 36 is equal to C squared. So I get 40 is equal to C squared. What would I have done at that step? What would I have done at that step to get C all by itself? What property did we just look at there? Yeah, so I'm going to take the square root of both sides. And if I take the square root of C squared, I'm going to get C. And if I take the square root of root 40, I'm going to keep root 40 for right now. But does everyone feel comfortable with that? Okay, now, we have our perfect squares. We know that we have 4, 9, 16, 25, 36, 49, etc. Those are our perfect squares. So do one of those combine with another number to give me 40? Do one, yeah. 36 times what gives me 40? Well, you can eliminate 49. We can eliminate 36. 25 times any number give me 40? I don't think so. 16 times 10? 4, yeah. 4 times what?
10.
Brandon, I still know you got a question. I'll come to you. So I get this. Agree? 4 times 10 is the same thing as 40. So that means I can go square root 4 and square root 10. Agree? What's the square root of 4? 2. So C is going to be equal to 2, because square root of 4 is 2, times square root 10. I can't do the square root of 10. Yeah, my calculator does. I know, but we're looking exact. Brandon, thanks for your patience. Oh, we'll take a look at it in a minute. Cool. Okay, so that took care of all those notes, yes? Okay, Could we do this? Could we take a look at what? I'm sorry. What page did I give you on homework? I'm sorry. I don't.
13, 14.
13, 14. I only asked you to do 13. Yes.
Yeah.
Okay.
I tried to. That's right. I tried to. I'm gonna 14.
Okay. So let's take a look at just page 13. Just page 13. Are there any questions on just page 13? Yeah. 5. Square root 108. Is that right? Okay. So I know my perfect squares are these. Let's see, 36, 49, 64, 81, 100. Okay. All right. So now let's start thinking. Okay. Are there any numbers up here that we can probably eliminate right away? Like, I'm pretty sure we can get rid of 100. Because 100 times some number is not going to give me 108, right? What about 81? 81 times some number give me 108? That, when you get that gone? Let's see, 64. Hey, 64 times 2 is 128. Well, that's probably not going to help either because I need to get to 108. Okay. Let's see, 49 times 2 is 98. 49 times 3 is way bigger than 108, so I can get rid of this as well. 36. 36 times 3? Is 36 times 3 108? That's right, you have the calculator. Yeah. It is? Really? So 36 times 3 is 108. So 36 happens to be the largest perfect square that's part of 108 if I were to multiply two numbers together. Okay? So I can break this down to root 36 times root 3. What's the square root of 36? 6. So notice this, the sign's gone because I took the square root. And then I get square root 3. And that square root 3 comes along, they're attached together. Yeah?
So I've been doing it kind of different. Like, I write the 108 at the top, then I do, like, the tree.
Okay.
Like, does that work too?
If your mind is seeing it that way, please keep doing it that way. Absolutely. Okay? Yeah.
So whatever number is able to be, well, is able to, less,
Well,
made less itself,
Mhm.
and then the other one doesn't.
right.
So then you add it together, like multiply together, and then you add it to the same. How about if both of them were able to?
Then you would add, the thing would have been perfect square.
Oh.
So like, let's say you chose, let's say we had 81. And you're like, oh, 9 works. Well, 81 is perfect square, right? But let's say you saw, oh, well, 9 times 9 is 81. Well, all of a sudden, well, square root of 9 is 3. And square root of 9 is 3. Well, it goes to 9. Well, square root of 81 is 9. So it works that way. B.
Like, number 5.
5?
I didn't do 36. I didn't go up. I did 4.
Okay.
That'd be incorrect.
Yeah, so you'd miss one point because you didn't, you found a perfect square that was part of it, but you didn't do the biggest perfect square. Does that make sense? Yeah. Number 6. Square root of 96, is that it? Square root of 96. Okay, again, I'm going to go to my perfect square. So I know I have 4, I have 9, 16, 25, 36, 49, 64. That's probably as far as I need to go. I could probably, real quick, say 64 is not going to work because 2 times 64 is 128. What about 2 times 49? What's 2 times 49? 98, I think. So can I cross off 49? Yeah. 36 times 3 we just found to be on the last one. What about 36 times 2? That's 72. 36 we can probably cross off. We can automatically cross 25 off because, yeah, 5 doesn't go into the, yeah, good. Okay. What about 16? Like 16 times 6? Does 16 times 6 work? What is 16 times 6 96?
Yes.
Cool. So 16 times 6 works. So 16 times square root 6. If I take the square root of 16, I get to 4. And I get 4 square root 6. Okay, so hold on to that sheet, and we're going to switch gears to another set.
Number, the 22, that's fine.
Oh, try it tonight now. Now we have the lesson. We'll do that tonight. Okay? So let me get out your second set of notes. And this is reinforcing what we did. So I think this will fill some of the gaps you might have. So keep the homework that I had assigned you, and you're going to do the back side of it as well. Okay? So the homework that's sitting on your desk right now, don't turn in to me today. We'll do that on Monday. Simplified radicals with variables. Let's move on. Okay, so warm up. So I think you can see your hint. I think you can see this. It's maybe off to the side of your page, right? Okay, so I'll bring it right there. Okay, so let's talk about 125. So which one of these is going to work with 125? 4? Well, let's go to the bottom. 144, nah. 121, no. 100, no. 81, probably not. 64, What's going to work? 25. 25 definitely works. So this is the same thing as 25 times 5. Yes? What's the square root of 25? 5. So I get 5 square root 5. Do I have to break? Can I just go right to that step? I think you could. Problem number 2, what's my first step? Multiply the outside. Good. So I'm going to get 10 on the outside. Second step is do what? Multiply the inside. So 15 times 20 is 300, I believe. Did someone double check that? Never trust my math. Okay, so let's look at my perfect squares. What's the largest perfect square that's going to work in 300? 300, so it's going to be some number times some other number. 100? 100 times 3? Yeah. Okay, so this is 100 times 3. Agreed? What's the square root of 100? 10. Is there a 10 outside that we're going to combine it with? Yeah? Let's see if you can see what I just did. What did I just do? Took the square root of 10, or 100, which was 10, and I multiplied it with the other 10 already outside. Hey, will somebody help me with, what's 72 times 18? I don't know. If you have a calculator, it'd be really helpful.
1,296.
1,296? Is that right? Okay. Okay. Now, let's take a look at our perfect squares. We go up to 144. Obviously, there's way more perfect squares than that, but let's just start with 144. Will someone go 1296 divided by 144? Tell me if it comes out to just a whole number. 1296 divided by 144. What'd you get? 9? Really? So you told me that this is the same thing as 144 times 9? Is that right? Josh, this is one that you asked me. Oh, watch this.
Yeah, it is.
What's the square root of 144? 12. What's the square root of 9?
3.
Is there anything left under the radical? So now I'm going to multiply these together. That's going to give me 6 times 12, which is... There's no radical on this one. Why is that? 1296 happens to be a perfect square. Will someone just on your calculator, for the heck of it, go square root of 1296 and tell me what you get? Square root. Oh, you squared it. Yeah, do square root. Second. Do the second of.
Second square root. 12, 12, 96. What do you get, buddy?
36 is 36 times 272.
Yeah, baby. Work that way.
Huh. A little bit further. Oh, no. Yeah.
On tests, are we gonna be able to see like will you have the perfect squares?
I will list them up here on the board someplace for you.
Okay.
A little bit bigger font than this.
Ooh, my favorite.
Week from today. Or it's a quiz. What do y'all think? I have the square root of 4x squared. So let's talk about what this is. Square root of 4. You guys know what the square root of 4 is? 2. You feel comfortable with that? X squared is the same thing as XX. Do you agree with that? Okay, so let's think about what this is. If you have a calculator out, find your x squared key. What is the second function of the x squared key? It's on the calculator. What do you think?
Oh.
Yeah, so what? So if you found x squared, right? It's a square root sign, right? Is that sign? So the square root sign and the square sign, they undo each other. So what is the square root of x squared? X. So this answer is 2x. Okay, let's build upon that thought in a sec. Okay, so the square root of 4x squared has an answer of 2x. Because x times x happens to make a perfect square. The reason why x times x makes a perfect square is think about the area of the square in the Pythagorean theorem. A squared, side A, has a square off the side of it, where a squared is the area. Okay? Okay. So the square root of x squared we just said was x. So this is square root of what is this right here? X times x, if I multiply together? X squared. What's the square root of x squared? X. What's the square root of x squared? X. What's x times x? X squared. So the square root of x to the fourth is x squared. Let's see if we can figure this one out. How many x's are listed all in a row? 6. So if I take 2 of them at a time, take the square root of 2 at a time, I get an x, and an x, and an x. So that gives me x to the third. Let's throw one right here. X to the 100 is equal to x to the 50th. You see that pattern? And I thought that was good to throw that one in. Because, of course, if you came across something that said x to 100, you're like, dude, are you kidding me? It's cutting in half, right? That's all it's doing. You're just cutting in half. Now, so it better be even, right? Because you can take half of even numbers. But look at this next one here. I have square root of x to the third. So let's think about what this is. Agree? Now, what did we just do up above? What was the basic? I found a pair, right? So what's the square root of this? X. What's left in the radical because there's no longer a buddy? So x square root x. That's your answer. It wasn't an even number, so we couldn't take half of it.
What do you say? Oh, I see.
See that? X root x. X to the fifth. Let's talk about x to the fifth. X to the fifth is this. Right? What's the square root of that? X. What's the square root of that? X. So x times x is x squared. That's outside, right? What's left inside? An x. X squared Square root x is our answer. So what is the answer to the square root of x to the fifth? X squared square root x. They both go with each other. Bless you. How we doing? Am I hurting anyone's brains yet? If so, I apologize, kinda. Alright. So, this is just information that we just knew, right? We called on the last screen, we called this, yeah? Look what they called it. Does that make sense? They combined two of them together to get x squared. And then you have to realize, hey, I can break down this. I can get x square root x for an answer. Why? I had x squared. I had x to the even power, so I'll take half of that. And then this one. So I take half of x to the fourth, and I get x squared. That's outside. If I take square root of x to the fourth, I get x squared. And I'm left with x. Okay, and again, that's just exactly what we did. Now, some people might always see it this way. They might say, you know what? I see it like this. And I see that I have to do this to find my pairs. And you know what? Your brain works correctly if you see it that way as well. Some people will tell you, oh, no, you don't think my way. You're thinking wrong. Are you kidding me? We're all different and beautiful for a reason. We don't think the same way. We're not ants. I'm going to pull this guy in front of me. Heck no, I'm going to do my own thing. I'm gonna do life and have fun. Go here. Oh boy. Oh boy. So I have square root 20, and then I have x to the 7th. Let's not run a million miles an hour all at once. Let's do this. I'm going to make a bigger radical sign, square root sign. Radical, square root, go with each other. What is the largest perfect square that goes into 20? 4. So let's make that a little larger so we can see it. So 4. Come on, baby. Okay. So everyone feel comfortable saying, hey, 4 works. And I know that 4 times 5 is the same thing as 20. Yes? Watch this. If I were to break x to the 7th down to x to the 6th times x, is that going to be x to the 7th if I put it back together? And Brandon said a key thing. He said, hey, if it's even, you just take half of it. Is my exponent on one of the x's right now an even number? Right? Yeah. So, let's do this. This right here, square root of 4 is what? 2. Everyone feel comfortable with that so far? The 5 is going to be left inside, agree? What is the square root of that? Yeah, it's x to the 3rd. Good. You take half of it. What's left underneath my square root sign? An x. What else? 5. And a 5? So 5x. So this right here is my exact answer. Huh. I think I'm starting to understand this. It'll only take me 22 years of teaching it. You should have seen me in my first year, man. I sucked at it. I don't want to ask other teachers for help. How do you do this, man? Calm down, Chris. You'll be all right. Okay. Let's take a look at this one. Now, I'm going to do this. I'm going to erase that for a moment. I'm going to do this. And I'm going to do edit. And I'm going to do copy. And I'm going to go here. And I'm going to go edit. And then I'm going to go paste. And I'm going to move it. Yay, baby. Okay. Anyone see see anything special with 36 under the square root sign? Yeah. It's a perfect square. This was done for us. Sweet. So I have square root of 36. X squared is already even number, so I'm not going to change that. Hey, what am I going to change y to the third to so I have one of them being even? What am I going to change y?
Y to the second.
Say it. Say it, sister.
And then another y.
There you go. Done. Okay, got it? Square root of 36. We'll set it back here as being 6. Square root of x squared. X. Take half of it, right? Half of that is 1. Could I put x to the first, do you think? Sure. Is it required? No. Is it wrong? No. What's the square root of y squared?
Y.
Do I know what the square root of y is? No. It's still left behind under the radical sign. Done. Woo! Woo! Can I move on? Uh-oh. 200. How can I break 200 down? Largest perfect square.
100.
So 2 times 100, everyone agree? Is a squared, is that even exponent? Yeah, leave it alone. How do I make b to the third? One of them be having an even exponent. B to the second and b. C to the fourth, is that an even exponent? Sweet. All right, let's do this. I can't do that, so that 2 is going to have to stay behind. What's the square root of 100? 10. What's the square root of a squared? A. What's the square root of b squared? What's the square root of c to the fourth? C to the second. What's left behind? A 2 and a b? Agree? So 10abc squared radical 2b, or square root 2b. Oh, I love this stuff. Oh, man, what do we got? Wait, where am I at? Here. Last one, isn't it? Is it the last one? Yes? Yes? Can we do it? All right. Multiply inside. 18. I don't want to make my radical. Oh, hang on. Let's do this. File. Paste. Move ya over there. Cool. Love it. Okay. 18 times 10 is 180. Okay, we'll break that up in a minute. Uh-oh. Like bases. When being multiplied, what do I do to the exponent? Add them. So I get x to the third times x to the fifth. I add the exponent, so I get x to the what? 8. Hey, is x to the 8th a perfect square? It's even, so it better be. Okay, cool. Then I have y squared and y. You know, I'm actually going to keep that as y squared y. I'm not going to change it to y to the third because y squared is a perfect square. Agree? All right. Hang on. Let's see. Largest number that go into 180. 144 won't work. 121 won't work. That won't. 64 times. No. 49. No. 180 breaks down to 9 times 20. 9 times 20. Hey. Hey, go 180 divided by 36, please, real quick. Five? Thank you. 36 is my largest perfect square. Watch this. I'm going to do it quick. 36 times 5, you said. X 8, y squared. Y. What's the square root of 36? Square root of x to the 8th. Sit down. Square root of y squared. And then 5y come along. Okay. Ladies and gentlemen, my friends. Okay, I want you to do this. I would like, so you had page 11, 12 the other night, right?
No,
13, 14, okay. So I want to make sure you have page 14 done and page 15, 16, evens on page 15, 16. Hey, what are evens? 2, 4, 6, 8, 10, 12. Right?
Thank you.
Have a great weekend, everyone. Take care of one another. Make sure you do the Schoology.